The aim of this experiment is to establish the relation between the loss in weight of a solid when fully immersed in tap water and then in strongly salted water, with the weight of water displaced by it by taking at least two different solids. So the material required is a spring balance, an overflow can, a brass bob, a glass stopper, spring balance, tap water, strongly salty water, and a physical balance. First of all, take a spring balance, check if there is any zero error, and also note down the least count of the spring balance. Then, using the bob, measure the weight of the bob when it was freely suspended in air using the spring balance. Let us see how this is to be done.
The spring balance we are using is designed to measure weights from 0 grams to 500 grams, and the least count that corresponds to each small division on this spring balance is 10 grams. So between 0 to 50 we can see there are 5 subdivisions where each subdivision corresponds to 10 grams. So the least count of this spring balance is 10 grams. Let us now check the mass of the bob that we will be using to perform this experiment with the help of this spring balance.
Now measure the weight of the bob when it was immersed in water using the same spring balance, and let the water that overflows be collected in another vessel. Later we will also check the weight of this displaced water. Let us see how this is to be done.
It is required for performing this experiment is we will be using two beakers, one of 100 ml capacity and the other one of 500 ml capacity. We need a spring balance and a bob. So let us first weigh this bob using the spring balance and check its weight. So the bob weighs 70 grams as you can see here on the spring balance. We have filled this beaker with water to the brim and weighed it. Now we will place this beaker inside this empty beaker and we will immerse this bob, which we have already weighed in air, into this small beaker. You can see that some water has spilled out into the larger beaker. We will now weigh the water that has been spilled in this beaker, and this will help us verify Archimedes' principle. The loss in weight of the bob is equal to the weight of the liquid displaced here, and that is also equal to the buoyant force that acted on this bob when it was immersed in water. So we have performed this experiment using tap water. You can repeat the same using salt water, and when you will do it using salt water, you will find that the amount of liquid displaced is more, showing that buoyant force is stronger in salt water because its density is more, and that proves that density directly affects the buoyant force, or the density is directly related to the buoyant force acting on any object.
Let us now fill in the observation table. We noted that the least count of the spring balance that we used was 10 grams. The weight of the bob in air was 70 grams. When we immersed the same bob in water, it weighed 60 grams. So the loss in weight was 70 minus 60, that is 10 grams, and the weight of water displaced was approximately 9.8 grams within experimental error. So the results tell us that the weight of displaced water is equal to the loss in weight of the solid within experimental error. Hence, Archimedes' principle is verified.